Okay, so today we are going to discuss the October 2021 Further Pure Mathematics paper 1. Let's start with question number 1. So they say here the matrix A, it's a 2 by 2 matrix. They say here A is a non-zero constant and A is not equal to 3. Simple, A here is a non-zero constant and A is not equal to 3. Determine A inverse, giving your answer in terms of A. Okay, so how do we find the A inverse? The first step towards finding your A inverse is to find the determinant of your matrix. So how do we find determinant of the matrix? First you take the elements along the main diagonal, multiply the elements in the main diagonal, then subtract it from the product of the other diagonal. So 3 times minus 2 is the product of the elements in the main diagonal. Subtract it with the product in the other diagonal, minus 2 times A. So I get here 3 times minus 2 is minus 6, minus minus is plus 2A. Is that okay? And then A inverse. How do we get A inverse? So A inverse is 1 over determinant A. And then what do we do for the elements? What do we do for the elements? Along the main diagonal, the elements are along the main diagonal, elements are switched. Along the other diagonal, the signs will change. Okay, so here the main diagonal elements, when they switch, I get here minus 2 and 3. So they are switching places. Minus 2 and A becomes plus 2 and minus A. So put the determinant here, 1 over determinant A is minus 6 plus 2A. And then continue the rest of it. So you get here minus 2 minus A, 2 and 3. That's it. So this is your A inverse, just 2 marks. Okay. Then part B. Given that A plus A inverse equals I, so I think you all know I means the identity matrix, a 2 by 2 identity matrix. In the identity matrix, only the elements in the main diagonal are 1. Every other element is 0. So they are asking to determine the value of A. So they are saying here A plus A inverse is equal to I. Okay, so who is A? A is the matrix capital A is 3A minus 2 minus 2. A inverse, we just found it, right? 1 over minus 6 plus 2A times your matrix is minus 2, 2 minus A, 3. So, and this is equal to I. I means 1, 0, 0, 1. This is the identity matrix. Only the elements in the main diagonal are 1. Everyone else is 0. Okay, so now what do? We need to solve it. You could take element along one single line and solve it. Okay, so your task is to find the value of A. So choose any line. Doesn't matter what you choose. If you want to take the first element in each of these matrices, make an equation. All you have to do is to create the equation. So to create the equation, you could create by using any one of these elements. Just choose one. So if I choose which one is the easiest, there one that is the easiest. So it doesn't matter, you could go with any way you want. If I choose the very first element in this matrix, I have to choose the very first in the other and the first in the other. So what do I get when I create the equation here? I get 3 plus, is it just minus 2 here? No, you know the 1 over minus 6 plus 2A is multiplying with every single element here, right? So you get here 1 over minus 6 plus 2A times the minus 2. Right, so that's what happens. This multiplies with the minus 2. So this is equal to 1. So you see how I created the equation? You could create the equation basically from any of the elements by using the second element, the third or the fourth. You could create your equation. It's totally up to you. Now it's the simplification and making A the subject. To simplify and make it a subject. 3. This becomes minus 2 over minus 6 plus 2A. So I think minus 6 plus 2, if it's confusing you, you could rename this as 2A minus 6. Is that okay? Minus 6 plus 2A is the same as 2A minus 6 because I'm worried you would make the minus mark in front and cancel it out. So just don't do any mistakes like that. So I'll just rewrite it like this. 3 minus, okay. So then we get this. The next step is towards making A the subject. I'll bring this guy here and I'll bring 1 over here. It's entirely up to you. The simplification is entirely up to you. 2 over 2A minus 6. So 3 minus 1 is 2. 2 times 2A minus 6. So you get here 2 times 2a minus 6 equals to, so I think you can see this whole equation is what? You could divide it by 2, right? You can cut out the 2. You can just remove the 2. The 2 will cancel out and you get here 2a minus 6 equals 1. Do you agree with me? So 2a equals 1 plus 6. That's going to give you 7. A equals to 7 over 2. So you could get this equation in many other ways. There are many other equations you could form by taking the second element, or you could take the third element or the fourth It doesn't matter. Okay, as long as you create the equation and simplify it correctly, you should get the answer properly. Okay. Question number 2. Fx is equal to 7 root x minus half x cube minus 5 over 3x where x is greater than 0. Show that the equation fx equals 0 has a root alpha in the interval 2.8, 2.9. Okay, so how do we show that there is a root? First thing is we must show that there is a sign change. So let's do the sign change. So we get here f of 2.8, right? Simplify. Replace x with 2.8, f of 2.8 and f of 2.9. So basically what you do is take your calculator and you type the whole equation in the cal in one go. So you get here 7 root x. You can type the equation in the cal, right? Half into x cube, half x cube minus 5 over 3x. Is okay. So type the equation correctly in the cal and give the values. So here calc when x is 2.8. So when x is 2.8, I get the answer for f of 2.8 as 0.1142. 0.14200, something like that, right? 1420022. Yeah. Then f of 2.9, just replace the x here, calc, replace x with 2.9 minus 0.8486. 8486, 421, something like that. Can you all see? So we have something, so we have a sign change here. There's a clear sign change. So there's a sign change and there's one more requirement for the to have a root in the interval. There must be a sign change and also your graph must be continuous. Okay, so there is a sign change and also definitely your graph needs to be continuous. So that word is really important. There is a sign change. There is a sign change and you must mention that your graph must be continuous in order for there to be a root, and fx is continuous, otherwise you don't have a root. Therefore root alpha is between, or alpha is in the interval, root alpha is in the interval 2.8, 2.9. Okay, so that's the answer for part. It's just 2 marks. Show the sign change and make sure you mention it. You need to give your conclusion. There is a sign change and fx is continuous. These words must be mentioned. It needs to be seen. Part B, Roman number 1, find f dash x. Okay, they want you to differentiate. Let's differentiate. Okay, so f dash x, how do we differentiate? This is part B, Roman number 1. So f dash x, before I go for f dash x, I think I need to rearrange my fx equation, because to differentiate, we should not have any x term in the denominator. So I get here 7 root x, in other words, is 7 times x to the power half. Are you with me? Minus half x to the power 3 minus 5 over 3x. When you bring the, now you can see x in the denominator. So when you bring it up, does the 3 also come out? So that's one of the main mistakes that many people do. The 3 will be down here. Do not bring it up. Just the x comes up. So 5 over 3 and we have x to the power minus 1. So now we are ready for f dash x. Get f dash x. F dash x is, take the power front. 7 into half is 7 over 2. X to the power half minus 1 is minus half. Minus half into 3 is minus 3 over 2. X to the power 3 minus 1 is 2. Minus 5 over 3 into minus 1 is plus 5 over 3. Plus 5 over 3. X to the power minus 2. Is that okay? So this is the f dash x. Roman number 2. Hence, using x naught equal to 2.8 as a first approximation to alpha, apply the Newton-Raphson procedure once. Very clearly they say to apply the Newton-Raphson procedure once to fx to calculate the second approximation to alpha, giving your answer to 3 decimal places. Okay, so many important things are there. You need to apply Newton-Raphson process once and give the final answer to 3 dp. First things first, what's the Newton-Raphson equation? Xn plus 1 equals xn minus f dash xn over fxn, right? Xn, the other way around, right? Sorry. Fxn over f dash xn. Okay, fxn over f dash xn. So then they have given you x naught. X naught is given to you as 2.8. So let's substitute, replace n with 0 and get x1 equals x naught minus f of x naught over f dash x naught. Replace the values here. Replace the values. Okay, so our x naught value is 2.8. Okay, so f of first thing is to calculate f of 2.8. So f of 2.8 was already calculated, right? Yes, f of 2.8 was already calculated, 0.142002. F dash 0.8 we need to, f dash 2.8 we need to calculate. So let me type the f dash equation in the cal. So don't press the on button. As long as you don't press it, you can retrieve every single formula you type. So I press the AC button, and when I press the down button, I can go back to every single thing I typed earlier. Okay. So because we might be needing to use the fx equation again, and we need to save time. So our f dash x equation is 7 over 2 x to the power minus half. 7 over 2 x to the power minus half. Minus 3 over 2 x to the power 2 plus 5 over 3 plus 5 over 3 x to the power minus 2. This is okay. 7 over 2 x to the power half. Yes. Okay, so then let's calculate the x value is 2.8. So when I give my x value, I get minus 9.45576. 7649, right? So just the thing is this, it's better that you give all the values. Okay, give all the values. Even for f of 2.8, I prefer you giving all the values. Let me go back. 7 root x. Yeah, this is the fx equation, right? In the fx equation also, when x is 2.8, what was the answer we got? 0.142022. So give all the values. Okay, so I have everything here. Now it's time to write it in the x1 equation. So x1 equals x naught is 2.8 minus f of x naught, or f of 2.8 was 0.1420022762 divided by minus 9.4557649. So type all of this in the cal and now give your answer 2 dp. What is the answer? 2.3 dp. There should be 2.815. So correct your answer 3 dp, and this is the answer that you need to get, 2.815. So okay, you can type it in the cal and check. Okay, then the next part. Moving on to part C. Use linear interpolation once. Again, linear interpolation must be used just once on the interval 2.8, 2.9 to find another approximation to alpha. Give you answer to 3dp. Okay, how do we find linear interpolation? So already I have f of 2.8. We already have it over here, right? F of 2.8 we found. It's a positive answer. Can I have the full figure? 1.0.4220022 The f of 2.9 answer 0.8486421. Yeah, the more you use the better. Okay, so then let's go for this one. Linear interpolation. So just draw a line. And what are your two figures? 2.8 and 2.9. So for 2.8, you can see you have a positive figure, right? Your y value is positive. The y value is 0.142 to this figure. And for 2.9, your figure is negative, right? Minus 0.8486 this figure. Okay, so linear interpolation is similar to what? Linear interpolation is similar to is the same as using the concept of similar triangles. Okay, so this is your alpha. The place where you draw this line is the alpha. So this is the concept that you will have learned already in F1. So what we do is we use the concept of similar triangles. So how do we write? The ratios between corresponding lengths are equal. The ratios of corresponding sides are equal. So the first corresponding side that I'll be writing is this side. 2.9 minus alpha over the corresponding length that is on the other triangle is this one, right? Alpha minus 2.8. The ones I marked in green are corresponding lengths for both the triangles. The next length that I'm going to mark, remember I'm using similar triangles, so I had to use lengths here. So the next length I'm using, I started from the first triangle. Can you see? So always go with the triangle you started. So in this other triangle, I know this particular length, right? What is this length? This length is this y figure here, right? 0.8486421.875 over the other corresponding figure here is we have in the other triangle 0.14200222762. This is I used all the values. Okay, so we need to give an answer to 3 decimal places now. Just solve the equation and give you an answer to 3dp. Okay, so let's solve it. I will put the dots here to say that all the numbers are coming. I'm not writing all the numbers. We can't afford to waste the time. So this is alpha times 0.848 and then minus 2.8 times 0.8486. So this value. So then take all the terms with alpha to one side and take the numbers to the other side. So this term has alpha, I'll take it to this side. And this term does not have any alpha term. Let's take it to the other side. Okay. So I get here 2.9 times 0.142 minus becomes a plus 2.8 times 0.848. The other figures I didn't write. And here I get alpha times. I could take the alpha out, right? I hope you guys can see that when I take this term to the other side, alpha is common. So I'll take alpha out and I get here 0.848. We'll continue the numbers afterwards. And this one is 0.142 and the remaining numbers. This is okay. So end of the day, we get here, when we make alpha the subject, we get alpha here as 2.9. Shall I write all the full figures now at the final stage? 2.9 times 0.14200222762 plus 2.8 times 0.848 6421875 divided by 0.8486421.875 plus 0.14200222762. Actually, you could type this in your calendar and also get the answer right in one go. You could type this equation directly and ask the calculator to solve it for you. It's a linear equation, so you can get the answers directly. So what is the alpha answer to 3dp? 2.814. The answer is 2.814. The quadratic equation 2x square minus 5x plus 7 equals 0 has roots alpha and beta. Without solving the equation, write down the value of alpha plus beta and the value of alpha beta. So let's get it done. Okay, so alpha plus beta value. How do we write the alpha plus beta value? Alpha plus beta is equal to minus b over a, right? So what's our ABC values here? You can see from this quadratic equation, a is 2, b is minus 5, c is plus 7. So then minus b over a, this is going to be minus, b is minus 5 over a is 2. So we end up getting plus 5 over 2. Alpha plus beta is plus 5 over 2. Alpha beta is c over a. So what's your c equation? C is 7, a is 2. So you get alpha beta is 7 over 2. So that's the answer for part A. Moving on to part B. Determine giving each answer as a simplified fraction the value of alpha square plus beta square and alpha cube plus beta cube. So these are two equations that are directly provided to you in your textbook. Okay, the two equations are provided. Alpha square plus beta square equation is given in your textbook directly as what? Alpha plus beta whole thing square minus 2 alpha beta. Okay, so it's provided in your textbook and this is a formula you are directly allowed to use. Okay, so directly use it. Alpha plus beta is 5 over 2 whole thing square minus 2 times alpha beta is 7 over 2 minus 2 times alpha beta is 7 over 2. How much is the answer? 25 over 4 minus 2 into 7 over 2 is 7. How much is the answer? Minus 0 minus 0.75, which means minus 3 over 4. Minus 3 over 4. So this is Roman number 1. Roman number 2, alpha cube plus beta cube. How do I get alpha cube plus beta cube? Again, the formula is provided in the formula. It's given in your textbook, the alpha cube plus beta cube equation. So can you all remind me what it is? What is the equation that they have given you? Alpha plus beta cube equation that they have provided to you is alpha plus beta whole thing to the power 3 minus 3 alpha beta times alpha plus beta. So again, this is a formula given to you, not in the formula book though, not in the formula book, but it's given to you in your textbook in this particular chapter, chapter 2. Okay, so let's input the values. Alpha plus beta is, we found the value 5 over 2. 5 over 2 whole thing to the power 3 minus 3 times alpha beta is 7 over 2 times alpha plus beta is 5 over 2. So let's work on this. 5 to the power 3 is 125. 2 to the power 3 is 8. Here I get how much? 3 into minus 3 into 7 into 5 is how much? Yeah, minus 168, right? 3 into 7 into 5, sorry. 105. The minus mark I have already used. So 125 over 8 minus 105 over 4 is minus 85 over 8. Minus 85 over 8. Okay, so we are done with that. Okay, let's go to part C. Find a quadratic equation that has roots 1 over alpha square plus beta and 1 over beta square plus alpha, giving your answer in this form. So when they ask you to find a quadratic equation that has these two roots, what is the format that we need to apply for part C? The format we need to apply is x square minus sum of roots times x plus product of roots is equal to 0. This is the equation. So basically you have your roots, get the sum and the product. Okay, get the sum and the product. Okay, so then we need to get the sum of roots and the product of roots. So what's the sum here? Get the sum 1 over alpha square plus beta plus 1 over beta square plus alpha. Get the sum and get the product. So what is the sum? To get the sum, you need to get the common denominator, right? So get the common denominator. I think, yeah, you need to get the common denominator. So this gives me alpha square plus beta times beta square plus alpha. Okay, so we have to take both the denominators together and it gives the common denominator. So this guy needs to multiply with the denominator it doesn't have. So this multiplies with the beta square plus alpha, right? Do you agree with me? The other one multiplies with the alpha square plus beta. So here I get 1 times beta square plus alpha plus 1 times alpha square plus beta. So let's simplify. Here I get beta square plus alpha square plus beta. The denominator is something that we know to work with. Now, if the values are now alpha square plus beta and beta square plus alpha, do you think these are two values that I know how to get the answer? Do we know the value of alpha square plus beta? No, right? So obviously the thing that we need to do is we have to open the brackets even in the denominator. Normally in denominators we do not open brackets, but here because we do not know the individual values of alpha square plus beta or beta square plus alpha, you better open the bracket in the denominator. And in the numerator, I can rearrange. Do you see? I can rearrange alpha square plus beta square and alpha plus beta. I just rearrange beta square plus alpha square together and alpha plus beta together. Can you see? Just simply rearrange in the numerator. And denominator, when I open the bracket, what do I get? Alpha square into beta square is alpha square beta square. Alpha square into alpha is alpha cube. Beta into beta square is beta cube. Do you see me expanding the bracket? Beta into beta square is beta cube. Beta into alpha is alpha beta. Okay, so now look at these values. Are these values that we know? Yes, you can see alpha square plus beta square value we found in the earlier part. Alpha plus beta also we found in the earlier part. Alpha square beta square is alpha beta whole thing square. Do you agree with me? Alpha square beta square is another way of saying alpha beta, the square of the whole thing. And here I have alpha cube plus beta cube also we found earlier. And alpha beta. So all the values are there. Can you see? So all you need to do is to substitute these values. Alpha square plus beta square is. So let's substitute the values here. Alpha square plus beta square was what? Minus 3 over 4, right? Minus 3 over 4 plus alpha beta is alpha plus beta, right? Alpha plus beta is 5 over 2. Alpha plus beta is 5 over 2. Then in the denominator we have alpha square beta square is alpha beta, the product, whole thing square. So what's the alpha beta product? The alpha beta product was 7 over 2. Yeah. So 7 over 2, it should be whole thing square because alpha square beta square is alpha beta whole thing square. Plus alpha cube plus beta cube is minus 85 over 8. Plus alpha beta is again 7 over 2. So it's a matter of typing this whole thing in the cal and getting the answer. What is the answer we get? 14 over 41. We get 14 over 41. Okay, and then we got the sum of the roots. Now I need to get the product of the roots. So I'll do it over here. Let's do to get the product of the roots. Product of the roots is where you multiply. So our two roots are 1 over alpha square plus beta and 1 over beta square plus alpha. Multiply them. 1 over alpha square plus beta multiplies with 1 over beta square plus alpha. When you multiply, I think I already have the product of these two guys, right? The denominator opening alpha, because 1 times 1 is 1. The denominator alpha square plus beta into beta square plus alpha is done in the sum where I open the brackets in the denominator, isn't it? So I have already written that as what? Alpha square beta square plus alpha cube plus beta cube plus alpha beta. So even those answers I have, right? Alpha square beta square was 7 over 2 whole thing square plus alpha cube plus beta cube is minus 85 over 8 plus alpha beta is 7 over 2. What is the answer we get? The product is
1 over 41 over 8.
1 over 41 over 8. 1 divided by 41 over 8 means it's going to be 8 over 41. Okay, so now it's time to write our quadratic equation. So write the quadratic equation, x square minus sum of root times x plus product. So fill in the values. X square minus sum of roots is 14 over 41 times x, right? Plus product is 8 over 41 equals to 0. So I think the equation they want in integer coefficients, right? They told they want in integer coefficients. So multiply the whole equation with 41. So 41 into x square is 41x square minus 14x plus 8 over 41 into 41 is 8 equals 0. Okay, yeah. So this is the equation of the, this is the answer, the quadratic equation that has the roots 1 over alpha square plus beta and 1 over beta square plus alpha. Okay, question number 4. F is equal to z cube minus z square plus az plus b, where a and b are integers. The complex number minus 1 minus 3i is a root of the equation fc equals 0. Write down another complex root of this equation. Okay, you know always complex roots comes in conjugate pairs, right? So if minus 1 minus 3i is one root, the other root is minus 1 plus 3i. Okay, so the other complex root is minus 1 plus 3i. Okay, next one. So this is just one mark. Determine the value of a and b. Okay, before we go determine the value of a and b, first thing we do is we can use our two complex conjugate roots and actually find the quadratic factor that gives you these two roots. Okay, so what are the two roots we have? Minus 1 minus 3i and minus 1 plus 3i. So to get the quadratic equation, I can again use the same format I used earlier. X square minus sum of root times x plus product of roots equal to 0. So what's the sum of roots? Minus 1 minus 3i. I add it with minus 1 plus 3i. So minus 3i plus 3i will cancel off. Minus 1 is minus 2. Alpha beta is the multiplication. Minus 1 minus 3i multiplied with minus 1 plus 3i. What do you get? Minus 1 into minus 1 is plus 1. Minus 1 into 3i is minus 3i. Minus 3i into minus 1 is plus 3i. Minus 3i into plus 3i is minus 9. I into I is I square. So first things first, minus 3i plus 3i cancels. So you get 1 minus I square is minus 1, right? You all know I square is minus 1. Minus 9 into minus 1 is plus 9. So we end up getting here 10. So basically that's the equation, the quadratic equation that has the roots are, what are the two roots? We need to not write with x actually. Can you see the equation is given in terms of z? So because of that, we need to replace, it's not with x, it should be with z. It should be z square minus sum of roots times z plus products. So then your quadratic equation will be z square. The quadratic equation will be z square minus sum of roots was minus 2, right? Minus 2z plus product of root is 10. Do you agree with me? So this is the quadratic factor. Z square plus 2z plus 10 equals 0. Okay. So now the thing is I need to, this is just the quadratic factor of this cubic equation. So 2z cubed minus z square plus az plus b, when we factorize, we get one quadratic factor. Since this is a z square, do you realize that there is another linear factor remaining? Yeah. Okay, there is another linear factor remaining. Okay, so we need to get that linear factor. Okay, how do we get that linear factor? Okay, so what I'll do here is now we know that to create, I want to create this cubic equation, and I know the two complex now. We know there are three roots here. Out of the three roots, two are complex roots, and the remaining other one root should be definitely real. Should definitely be real because complex roots comes in conjugate pairs. So you already have a pair of conjugate roots. The remaining one root for the cubic equation must be real. Okay, so one method that we could do here is, now we know our z square plus 2z plus 10. I have to multiply it with another linear factor, right? Okay, we have to multiply it with another one linear factor to create what? To create the 2z cube minus z square plus az plus b. Okay, so definitely this equation has to multiply with another one linear factor. Now this has to be something with z, right? It has to be something with z. Okay, and then z, of course, with z means it's z plus some constant, isn't it? Okay, so now the thing is, you could kind of like use your common sense. You can see there's 2z cube here. So if there's 2z cube here, adding just a z, do you think it will create me 2z cube? Because z square into z is z cube. Am I getting 2z cube? No. And do you know that, I mean, you know that in none of the other terms when we multiply will give you a z cube, right? The only term to give you z cube is the very first term, isn't it? So then definitely do you realize that this needs to be a 2z? Then we don't need to waste a lot of time. Surely this must be 2z because z square into 2z is 2z cube. No one else in this equation is capable. I mean, when you multiply brackets, expand the bracket, no one else can give you a z cube. Okay, so 2z, and what else do we need? Now the other term is the mystery here. So they have used a and b here. Shall I use c here? 2z plus c, because we need, there is some value here, but I can't figure what that is. Okay, so what we'll do is now we'll do something called comparing coefficients. Okay, so before we compare the coefficients, shall I expand the bracket? So when I expand the bracket with z square, I get z square into 2c is 2z cube, z square into plus c is plus c times z square. Do you agree? And the next one is, this is 2z, right? So the next one is plus 2z into 2z. What do we get? Plus 4z square. The next one plus 2z into c is plus 2cz. Then the next one, I have to multiply with 10. 10 times 2z is 10 times 2z is 20z plus 10 times c is 10c. Okay, let's rearrange this equation. I want to create the z squares, z terms, and the, I want you to separate everyone. So you can see z cube only comes from one term. The next one is the z square. You can see z square is there in two terms. Both of them have z square. I'll take z square out and I end up getting here c plus 4. Do you agree? Then again, these two terms, they have z. So when I take z out, I get 2c plus 20 plus 10c. Can you see I've separated the z cube? Okay, 2c, right, 2z cube, c z square, 4z, okay, 2z, z, 20z, 10c. Wait, what went? This equation that I expanded must definitely be identical to what? It must be identical to this person. Like, let's say it's identical. Right? Because obviously when I multiply these two factors, I need to create this. So these two are what I have here should be identical to this. So z cube I don't need to compare. Z cube I don't need to compare. The z cubes are already same on both the sides. Let's compare the z square coefficients. So when I compare coefficients for z square, z square, what do I get here? C plus 4 here. On the other one, minus 1. And you see I can get the value of C. C is equal to minus 5. Okay, C is the value that I input. Let's go for the next comparison. Next comparison for Z. So what do we get for Z? When I compare Z, I get 2C plus 20. For C, I get A, right? So then C is minus 5. 2 times minus 5 plus 20 equals A. 2 times minus 5 is minus 10. Plus 20 equals A. A is 10. Then compare for the constant. So when you compare for the constant, I get here 10C equals to B, right? So 10 times C is minus 5 equals to B. I get minus 50 equals to B. So this is the answer. These are the answers we get for A, B, C. In the next one, show all the roots of fz equals 0 and an Argand diagram. So what are all the roots? So I think you can see the fz equation. This is part C, right? The fz equation, when we factorize, we get z square plus 2z minus 2z plus 10 plus 2z plus c. C is minus 5. So these are the two brackets I have. Okay. So then what I do here is they want us to draw all the roots on the Argand diagram. So what are all the roots? Roots are when these two, when the fz equation is equal to 0. So z square plus 2z plus 10 equals 0 or 2z minus 5. So basically I have the roots of this equation already, right? What are the roots? Z equals minus 1 plus or minus 3i, because we already had it in the part A. It was given to us. So we don't need to find it. We don't need to find it. It's given. And the other root is z equals 5 over 2. Okay, let's mark all three on an Argand diagram. So this is the real and this is the imaginary. So the first coordinate is minus 1 plus 3i. So minus 1 plus 3i. The next equation is minus 1 minus 3i. And the next equation is just 5 over 2, right? So 5 over 2 plus 0i. Do you see there's no imaginary coefficient? So it's basically 2.5. So when I draw the complex numbers, this is what I get. Okay, so these are the three complex numbers. So this coordinate is minus 1 comma 3. This coordinate is minus 1 minus 3. And this one is 2.5 comma 0. Okay, show all the roots of the equation fz equals 0 on a single Argand diagram. So this is the answer. Okay. Okay, question number 5. Use the standard results for summation r cube r square r to show that for all positive integers n, the summation of r times r minus 1 times r minus 3 is equal to this. So it's a show that, and it's 5 marks. Be really cautious because it's a show that you need to show you're working very clearly. Okay, so then I have written here the standard results, including the summation of 1, all from 1 to n. So the standard results are given. All we need to do is to expand the bracket and to simplify, to substitute. Yeah, basically. So let's open the bracket, summation r times r minus 1 times r minus 3. Let's open. So summation 1 to n r times, let's open the bracket, r minus 1 into r minus 3 is r into r is r square, r into minus 3 is minus 3r, minus 1 into r is minus 1r, minus 1 into minus 3 is plus 3. So basically we get summation r times r square minus 4r plus 3. So when you open inside, now open inside with the r, we get here r cube minus 4r square plus 3r. Okay, so then the summation goes from 1 to n. Okay, so now let's simplify. Open the bracket, the summation 1 to n, summation r cube minus 4 times summation r square plus 3 times summation r, all from 1 to n. And now it's a matter of inputting the equations. Summation r cube is 1 over 4 n square n plus 1 square minus 4 times summation r square is 1 over 6 n plus 1 2n plus 1 plus 3 times summation r is n over 2 n plus 1. Okay, so then in the show that I can see they've taken, we need to take the common things out as much as possible. So one thing I can see common here is n and n plus 1. Shall I take n and n plus 1 out? Then I'm remaining here with 1 over 4 n times n plus 1 minus n plus 1 goes here. I get 4 over 6. N plus 1 goes out. 2n plus 1 remains. 4 over 6 can be simplified as 2 over 3 as well. Okay. Here 3 over 2 is remaining. N and n plus 1 is gone out. I'm taking n and n plus out from n plus 1 out from all these three. Okay. And then when I look at the show that I can also see they've taken a 1 over 12 out. Okay, I don't need to have all these factors here. Let's take 1 over 12 out. So basically when you take 1 over 12 out, what does it mean? Inside all your terms are what? Are multiplied by 12. When you take a number out as a division, it means the inside terms are multiplied. When you take a number out as a multiplication, inside terms are divided. So here 1 over 12 means all your inside terms are multiplied by 12. So 1 over 4 times 12 gives you 1 over 4 times 12 give you 3. 3n times n plus 1 minus 4 over 6 times 12 gives you 8, right? 4 over 6 into 12 is 8 times 2n plus 1 plus 3 over 2 into 12 is 18. So open the bracket and let's simplify. 1 over 12 n plus 1. Now open the bracket. Inside you will get a quadratic equation. 3n square plus 3n minus 8 into n is minus 16n minus 8 into 1 is minus 8 plus 18. So what do we get here? 1 over 12n n plus 1 3n square plus 3n minus 16n is minus 13n minus 8 plus 18 is plus 10. So you all can factorize this now. 3n square minus 13n plus 10. What are the two factors? 3n minus 10 and n equal 1, n minus 1. So these are the factors. And this is to show that, yeah, 1 over 12 n plus 1, they have n minus 1 and 3n minus 10. It doesn't matter, right? So it's a product. And we get the answer. Okay. Okay, so in part B, they say you hence show that the summation of R from n plus 1 to 2n plus 1 of R minus 1, R minus 3 is given by this formula. Okay, now the thing is this. The thing is the summation formula that we proved in part A. Now you can see this is the summation formula we proved in part A, right? So this summation formula is only valid when we start from where? It's only valid when we start from 1. It needs to start from 1. Okay, so if you have 1 to 10, you can immediately replace the n with 10. If you have it from 1 to 100, you can replace your n with 100. However, the thing is it must start, the summation must start from 1. Now the problem here is our summation, does it start from 1? No, it starts from n plus 1 to 2n plus 1. So I don't mind where it ends, but the starting place needs to be 1 in order for us to use this part A equation. So to do that, we have a formula that we learned in F1, right? So if your summation is there from a middle value instead of 1, if you have a middle value, A to n summation, what do? We get the summation from 1 to n, like 1 to from the very beginning to the very end. And we subtract the terms we don't want. What are the terms we don't want? We don't want the terms from 1 to, now I want from A, right? So I remove the terms from 1 to A minus 1. I remove the terms from 1 to A minus 1. Okay, so this is a standard equation, a standard formula. So let's use this equation. Okay, so what I do here is I'll take the summation from R equal, now we need the summation from R equal n plus 1 to 2n plus 1, right? So I'll use here FR instead of R minus 1, R plus 3. So look, this summation we can take it as the summation from R equal 1 to where? Starting from 1 to 2n plus 1, because that's the beginning from 1 and we end at 2n plus 1 minus the summation of from R equal 1 to where? Now here we start with n plus 1. Therefore, we need to end here with 1 before that, isn't it? Here we have A, we have 1 before A. N plus 1 before that is n, FR. Okay, so here your FR means, basically your FR here means the R minus 1, R minus 3. That's what it means. Minus here the summation from R equal 1 to N means R minus 1, R minus 3. Now look, I already have a summation formula that we proved. If you have from 1 to N, then just replace the N value. If it's 1 to 10, replace the N with 10. Now here what do I have? From 1 to, I have the summation formula from 1 to 2N plus 1, which means all the N values must be replaced by what? All the N values are replaced by 2N plus 1. Let's replace. All the N values are replaced by 2N plus 1. So 1 over 12. N is replaced as 2N plus 1. N is replaced as 2N plus 1. Let me do it from a different color, right? All the N's need to be replaced. So all the N's here are replaced, okay? So let me do it again with a different color. 1 over 12 times N is 2N plus 1. The next one, N plus 1. 2N plus 1, that is N. And separately plus 1. Are you seeing what I'm doing here? I'm replacing every single N with 2N plus 1. Okay? N minus 1. Again, open bracket. N means 2N plus 1. And then there is this minus 1 here. Do you see? Here the N is replaced as 2N plus 1 and then there's minus 1. The next bracket has 3 multiplied by N, right? Close this bracket. 3 multiplied by your N is 2N plus 1. This time you need to put your 2N plus 1 within a bracket. Because 3 multiplies with 10, right? So 3 multiplies with 2N plus 1. And then there is minus 10. Can you see? So this is just inputting the first value. And then you have to subtract this from what? The summation of this equals the summation of this formula from 1 to N. 1 to N, of course, is fine, right? 1 to N I already have. 1 to N is directly given to you. So that is 1 over 12, N, N plus 1, N minus 1, 3N minus 10. Okay, so then what we'll do here is 1 over 12. Let's simplify inside each bracket. 2N plus 1. This bracket becomes 2N plus 2. Are you following me? I'm going through this order. 1 over 12 into 2N plus 1. This bracket 2N plus 1 is 2N plus 2. This one 2N plus 1 minus 1. Plus 1 minus 1 cancels, right? Into 2N. The other bracket will, of course, you have to open the bracket. 3 times 2 is 6N. 3 times 1 is 3 minus 10. Can you directly tell me what it is? 6N. 3 minus 10 is minus 7. So we get 6N minus 7. 6N minus 7. And then minus 1 over 12 times N. N plus 1. N minus 1. 3N minus 10. Okay. So now let's work on this. I need to get the show that. What kind of a show that do they have? In the show that they've taken 1 over 12 N and N plus 1 out. So shall we do that? Do we have 1 over 12 N and N plus 1? Let's see. Let me simplify this. 1 over 12 2N plus 1. In 2N plus 2, do you see if I take a 2 out, I create N plus 1 here. In this 2N plus 2 bracket, if I take a 2 out, I get N plus 1 times 2N times 6N minus 7. Okay, this part is the same. I'm just repeating the same thing again. Now I'll take the common thing out. We are anyway supposed to take 1 over 12 N and N plus 1 out. Are you all with me? I'm going to take 1 over 12 N and N plus 1 out. So 1 over 12, the N and the N plus 1. So you also 1 over 12 N and N plus 1. All these guys go out. So who is remaining now? 2N plus 1 is remaining. Times 2 is remaining. Another times 2 is remaining. Times 6N minus 7 is remaining. Are you with me? Minus, in the middle there is a minus mark. 1 over 12 when n plus 1 goes out and you're remaining with n minus 1, 3n minus 10. Is this okay? Okay, is that okay? So you are remaining here with 1 over 12 n plus 1. Let's open the bracket. 2 times 2 is 4 here, right? Open the bracket. 2n minus 2n plus 1, 6n minus 7 is 2n into 6n is 12n square. 2n into minus 7 is minus 14n. No, 2n into, yeah, 2n into minus 7 is minus 14n. 1 into 6 is plus 6n. 1 into minus 7 is minus 7. Minus, now be careful, there's a minus sign out here. So you better put a bracket when before you open the bracket. N into 3n is 3n square. N into minus 10 is minus 10n. Minus 1 into 3 is minus 3n. Minus 1 into minus 10 is plus 10. Okay, I'm writing all over the place, but you need to write it neatly because of space and because of the amount of space in the screen. I'm writing it a constraint. So you write it down properly. 1 over 12 n plus 1. Open the brackets. I get here 4 times 12 is 48n square. Simplify these two before you open. Minus 14 plus 6 is how much? Minus 14 plus 6 is minus 8n. Minus 8n times 4 is minus 32n. The next one, 4 times minus 7 is minus 28. Can you all cope up with what I'm doing? Okay, I simplify these two before I multiply with 4 because it's easy and it reduces us some steps. The next one is you open the bracket with minus 1 into 3n square is minus 3n square. Minus 10n minus 3n is minus 13n. Minus 13n, when you multiply with the minus sign, it becomes plus 13n. The next one, minus into plus 10 is minus 10. Let's simplify 1 over 12 n plus 1. I get here 48 minus 3 is 45n square, right? Minus 32n plus 13n. How much? Minus 19n. Minus 28 minus 10 is minus 38. Okay, so does it factorize well? They're asking us to get the quadratic equation, right? Yeah, they're asking us to get 1 over 12 n plus 1 an square bn plus c. So an square bn plus c is 45n square minus 19n minus 38, which is exactly what they wanted. They wanted us to get an answer of this time. And that is, this is the answer, an square plus bn plus c. Okay, so this is the answer. Okay, the curve H has equation xy equal a square. Okay, where a is a positive constant. So number one thing is in F1 in the lesson, in this particular lesson, this is chapter 2, where you have the parabola and where you have the rectangular hyperbola. Parabola equation was given to you as y square equals 4ax, and the hyperbola equation in the book they have given you xy equals c square. So here they have given the curve H has the equation xy equal a square. Instead of c, they have used the a. So you need to identify this is the rectangular hyperbola that they are talking about. Okay, where a is a positive constant. The line with the equation y equal kx, where k is a positive constant, intersects h at the point P. Use calculus to determine in terms of a and k and equation for the tangent at P. Okay, so the line with the equation y equal kx, where k is a positive constant, intersects h at the point P. Okay, use calculus to determine in terms of a and k and equation of then equation for the tangent to the hyperbola at the point P. Okay, so what's the first thing we need to do here? The first thing we need to do here is we need to find the intersecting point, right? Okay, so shall we get the intersecting point? So we have here xy equal a square and our line equation is y equal kx. Shall we input our line equation? So xy equal a square. Okay, so I've drawn this the rectangular hyperbola along with the line y equals kx. They've said that k is a positive constant, so we need to understand the line goes through the origin. So just drawn a sketch here, and they have told us, by the way, they have told us x is greater than 0, right? Which means, do I need to draw the other side of the rectangular hyperbola? No, I can erase it. This side of the rectangular hyperbola can be erased because they've said here the graph is defined only for x values greater than 0. Shall I draw it again a little bit larger? So the rectangular hyperbola, we need to only consider it for the positive x values, okay? And then the line equal y equal kx is a line that goes like this. So it intersects the curve at the point P. Okay, it intersects the H at the point P. Then they are saying use calculus to determine in terms of A and K the equation for the tangent at P. So equation for the tangent means we need this line, right? So this is the tangent. Are you with me? I need to calculate the equation for the tangent. Okay, the first thing I need to do is I need to use the equation of the straight line y equal kx and solve it with what? And solve it with the hyperbola equation, not hyperbola, solve it with the rectangular hyperbola equation xy equal a square. Okay, so solve it simultaneously and get what? First get the coordinates of the point P. That's the first thing to do. Okay, and then we can go for the equation of the tangent. So let's solve it. Y equal kx. Let's substitute to xy equal a square. So replace y here. Y x times y is kx equals a square. So we get here x square times k equals to a square. X square equal a square over k. So x equals to square root a square over k. By the way, you know, normally when you apply the root, you get what? Plus or minus. This plus or minus would tell you normally, you know, when you take the full rectangular hyperbola, you know, there's another part of the hyperbola we draw here, right? So this part we have not drawn it now because our coordinates are specifically mentioned x is greater than 0. So therefore, I don't need to consider that. And here, I only need to consider which part of my root? Only the positive part of the root. We don't need the negative because our x coordinates are clearly supposed to be greater than 0. So when I simplify here, I get x equals, I can take the a square out of the root, right? X equals square root of a square is a over root k. Do you agree? A over root k. So leave it like that. And the other one, the y coordinate. I need the y coordinate also. So y equals kx. When I replace it in y equal kx, x is a over root k. So k divided by root k, what happens here? You could, I mean, we can simplify this a little bit by multiplying up and down with root k. And I end up getting here y equal k times a times root k divided by root k into root k is a k. And you can cancel out a k to k. So can you see the point P coordinate? The point P coordinate is a over root k comma a root k. You could rationalize it if you want and write a root k over k. Okay, you could rationalize it and write a root k over. That's perfectly fine. Okay, I want the equation of the tangent. So still I have not done what I wanted to do. I want to find the equation of the tangent. How do we normally find the equation of the tangent? The first thing is we need to differentiate the equation, right? We need to differentiate the hyperbola equation and get the dy by dx. That's what we do to find the gradient. Okay, because dy by dx is what? Dy by dx is the gradient of the tangent. Okay, dy by dx is the gradient of the tangent. So I'll have here, now I'm going to find dy by dx. My xy equation is a square, right? So let's make y the subject, y equal a square over x. Is that okay? In other words, y equal a square times x to the power minus 1. I brought the x up. Now it's ready to differentiate. So let's differentiate and get the gradient of the hyperbola at any given point. Basically differentiation. Dy by dx, a square is a constant. When you differentiate x to the power minus 1, we get minus 1 x to the power minus 2. Okay, so dy by dx is, when I simplified, minus a square. Shall I bring I brought the minus 1 forward. X to the power minus 2, shall I bring it down? Over x square minus a square over x square. Now what do we do? Replace now I need to get the gradient at this point P. So what should I do? I should replace this x with the x coordinate of the point P. This is the, just think yourself, think of what you would do if you got a numerical value here. So if you have a numerical point and you have a curve and you want to find the tangent to that point, you get the dy by dx of your curve and you substitute the point coordinate to the dy by dx. That's what you would do. So here, the exact same thing you do, even though it's with letters. It's the same process. So replace, so dy by dx equals minus a square over x square is a over root k. We need to square it. Okay, so what happens when we square it? Minus a square over, this becomes a square. Root k, when you square it, it becomes a k. So minus a square divided by a square over k. I hope you know what it means. Minus a square divided by a square over k is something like this, right? A square division to multiplication, you get k over a square. You don't need to remember all of this. Just showed you. You can directly say a square cancels and the k goes up. So you get here what? Your dy by dx value is minus k. Your dy by dx value is minus k. So now what do? We need to get the equation of a tangent. Let's get the equation of the tangent. So equation of tangent. Y minus y1 equals gradient x minus x1. So y minus y1, so the coordinates are given here, right? P coordinates were what? A over root k comma a root k. So y minus y1 is a root k, right? Gradient is minus k times x minus x1 is a over root k. This is what we get, right? And they ask us to get the equation of the tangent. What? Use calculus to determine in terms of a and k and equation for the tangent. Shall we rearrange this and simplify it? So I get here y minus a root k. Open the bracket with negative k. Negative k into x is minus kx. Minus k into minus a over root k is plus k8 over root k. So I think when I see k up and down, I feel I should rationalize and I feel I could cut a k if I rationalize, right? Can you see that? You need a little bit of experience to see that. So I get here y minus a root k equal minus kx. What happens here? This is k times root k times a. Are you with me? K root k into a. Here root k into root k gives you a k. And do you see the k to k cancels? So we get here y minus a root k equal minus kx plus root k times a. So I think we have like terms here, minus root k times a. Again, we have another one over here. Do you see a root k and another a root k? Yeah, so we create two of them. Y equal minus kx plus twice of 2a root k. Because the same thing is that y. So this is the equation of the tangent. Are you all clear with it? This is the equation of the tangent. Let's move on to the next part. Okay. The tangent to the hyperbola at P meets the x-axis at the point A and meets the y-axis at the point B. Okay, so the tangent meets the hyperbola at the point, the tangent to the hyperbola at P, okay, meets x-axis at A and meets y-axis at B. Now, by the way, we found the equation of the tangent to the hyperbola, right? So this is what we proved here. This was actually all we did in the previous part. Y equal minus kx plus 2a root k. This is exactly what we found, right? So basically what you need to do here, this equation y equal minus kx plus 2a root k. This is the equation of our tangent. Now they say this equation of the tangent meets the x-axis at the point A. If I refer my diagram, here this is the point A. Do you see on the diagram? It meets the x-axis at the point A and the y-axis at the point B. So if I make the sign a little bit longer, it meets the y-axis at the point B. Do you see it? the points A and B, having a small visual diagram is always, it helps us to understand what really goes on in this sum. Okay, so now what do we need to do? Determine the coordinates of A and the coordinates of B, giving your answers in terms of A and K. Okay, so when you meet the x-axis, what happens? When you meet x-axis or when you cut x-axis, your y is 0. So when your y is 0, we get minus kx plus 2a root k. Minus kx, I'll take to the side as plus positive kx equals 2a root k. So x equals 2a root k divided by k. Do you agree with me? 2a root k divided by k. Okay. So you could leave it like this, or you could, if you want, like you could, I mean, k is like, if you all want, you know, just to remind you all, k is like a root k into a root k. Do you agree if I say k is root k into root k? So then here, if you want like a root k with one root k cancels, and you can write 2a over root k for your x, if you want. Okay, so that's another way of writing, or else we could just leave it like this. Okay, then we'll do the other one, meeting the y-axis. So when you meet, okay, before I go for the y-axis, let me write the coordinate. The place where we meet the x-axis is the point A, right? The point A coordinates. Point A is 2a root k over k, right? Comma 0. And then meet x-axis, then meet y-axis. So when you meet y-axis, x is 0, right? X is 0. So make x 0, y equal minus kx becomes 0 plus 2a root k. So basically you get y equals to 2a root k. So point B coordinate is x is 0, comma y is 2a root k. Is that okay? Okay, then what we need to do is, yeah, so these are the points A and B. Determine the coordinates of A and the coordinates of B, giving you answer in terms of A and K. Done. Okay. Next one. Hence, show that the area of triangle AOB, where O is the origin, is independent of K. Okay, so how do we do this one? The area. Now, do you see the AOB triangle here, by the way? So, AOB is a what triangle? Right angle triangle. You can see AOB is a right angle triangle. The OA length is given by the x coordinate of A. The OB length is given by the y coordinate of B. Okay, the OB length is given by the y coordinate of B. Can't you get the area? So area is half into base into height, right? Because it's a right angle triangle. Or you could use half AB sine C, it's entirely up to you. So half into base, you could use the OA length, and height, you could use the OB length. Do you agree with me? Half OA length is the x coordinate of A. 2a root k over k times OB is the y coordinate of B. 2a root k. Do you agree with me? So here I can cancel off a half and a 2. And I end up getting here. There's a into a is a square, and there's a 2a square. Root k into root k gives you a k over k. Do you see? Root k is a k. A into a is a square. 2 is there here. Denominator, you have a k. What happens? The k and k cancels, and your area is 2a square, which is what? Which is independent of k. They ask you to show that your area is independent of k. Independent of k means there is no k term in the area. So you can see here in what I've done, hence show that the area of triangle OAB, where O's origin is independent of k. So that's it. There is no relationship, there is no involvement of k in this answer. Okay, so we are done. Okay. Okay, question number 7. In part 1, the elements of each matrix should be expressed in exact numerical form. Okay, exact form. Write down the 2 by 2 matrix that represents a rotation of 210 degree anti-clockwise about the origin. Once again, this is a theory that is given directly in your textbook. So I have written it here. Find angle rotated theta degree anti-clockwise about the origin, by the way. Find angle rotated theta degree anti-clockwise about the origin. The transformation matrix is given by cos theta sine theta minus sine theta cos theta. So I just read the column vectors. So all you have to do is what? Replace all your thetas with what? 210. So it's just 1 mark. Simply 1 mark. Input 210, cos 210 over sine 210 minus sine 210 cos 210. Can you all get me the exact numerical answers? Cos 210 is minus root 3 over 2. Sine 210 is minus half, minus 0.5. Minus sine 110, then it should be plus half, right? Cos 210 is again minus root 3 over 2. So this is just 1 mark. So this is all the effort we need to put. Okay. Next one, part B. Write down the 2 by 2 matrix that represents a stretch parallel to y-axis with scale factor 5. So this one, of course, I'll do it from the beginning. Normally, when we transform, we always use the base matrix 1, 0, 0, 1. Do you remember? 1, 0, 0, 1 is the matrix we use. So this is 1, 0, and this is 0, 1. So what happens when you stretch the y-axis with the scale factor 5? Only the y-axis is stretched, right? The y coordinates are multiplied by 5. So the other one, the 1, 0, the x is 1, the y is 0. That is not affected. So 0, 1 becomes 0, 5. So when you do the stretch here, your new vector becomes, the new matrix is 1, 0 doesn't change because you're doing it parallel to y-axis. 0, 1 becomes 0, 5. Okay, I hope this is clear to you all. Okay, next one. The transformation T is a rotation of 210 degree anticlockwise about the origin, followed by a stretch parallel to y-axis with scale factor 5. Determine the 2 by 2 matrix that represents T. So again, you need to remember your matrix theories. Do you remember followed by theory? If they say matrix A followed by matrix B, how do we do the multiplication? Do we write A into B or do we write BA? Matrix A followed by B. We write BA. The thing is A followed by B. We feel writing like this, but we should write it the other way. BA, matrix A followed by B. B is written in front. A is written afterwards. Okay, so I have to explain reasons for this in the F1 book while we are doing the lessons. Okay, so I'm not going to go into details about that, but basically when they say A followed by B is this, not this. Okay, so this is wrong. So again, once again in here, they have said the transformation T is the rotation about the origin followed by the stretch parallel to y-axis. So basically the transformation T is followed by the stretch, which means what? The stretch is written first, right? 1, 0, 0, 5, and then we write the transformation, the clockwise rotation is written afterwards. Okay, the rotation followed by the stretch. So when it's rotation followed by the stretch is written first and the rotation is written afterwards. This is the way we do in matrices. The reasons are explained while we were doing lessons. Okay, so I'm not going for the reasons now. Let's just multiply. Let's simply multiply. What do we get when we multiply 2 by 2 with 2 by 2? We end up getting another 2 by 2 matrix, right? So the first element is the first row and the first column. So 1 into minus root 3 over 2 plus 0 into minus 1 over 2 is directly minus root 3 over 2. Is that okay? The next one is 1, 0 with 1 over 2 and minus root 3 over 2. So that also 1 into half is half. 0 into minus root 3 over 2 is 0. So you agree with me? The next one is 0, 5. We multiply with minus root 3 over 2 and half. So 0 into minus root 3 over 2 is gone. 5 into minus half is minus 5 over 2. The last one, we multiply 0, 5 with half root 3 over 2. What do we get? 0 into half is 0. 5 into minus root 3 over 2 is minus 5 root 3 over 2. So this is the answer we get. Is that clear? Okay, let's go to the next part now. Next part, part 2. M equals K. Okay, they have given you a 2 by 2 matrix here. Can you see? They have given you the M matrix. Find determinant M, giving your answer in simplest form in terms of M. So how do we find det M? How do we find det m? So we'll multiply along the main diagonal. K times 1 minus k. The main diagonal elements are multiplied and then subtracted with the multiplication of the other diagonal. Minus 5 times k plus 3. So when you multiply, k into 1 is k. K into k is k square. Do you agree? Minus minus is a plus here. Okay. Minus minus is a plus here. 5 into k is plus 5k. Plus 5 into 3 is plus 15. Are you guys okay with it? So I get here the determinant of k is minus k square. Plus k plus 5k is plus 6k plus 15. Is this clear with you all? Okay, so when we move to the next part, a closed shape R is transformed to a closed shape R dash by the transformation represented by the matrix M. Given that the area of R, now in here the object image story comes into play, right? So we have a equation relating the area of the object and area of image. Do you remember? So area of object, what's the equation that we need to use in here? Roman number 2 part A, Roman number 2 part B. The area of object into determinant of M into det M. The positive value is equal to the area of object, area of image. So this is the equation you need to know. Area of object into determinant of your transformation matrix. It's like the scale factor. Your determinant of the transformation matrix is like the scale factor. So then it gives the area of the image. Now they have said here, given that the area of R means what? Object or image, R is transformed to the shape R dash. So if R is transformed to R dash, R is the object, R dash is the image. So given that the area of R is 2, which means object area is 2 times determinant of M is minus k square plus 6k plus 15, right? Equals area of image is what? The area of image is 16k. You see? So basically we end up getting what? Solving a quadratic equation. Solve the quadratic equation. Minus 2k square plus 2 times 6 is 12k plus 2 times 15 is 30 equals to 16k. So take all the terms to one side. 0 equal positive 2k square. 16 minus 12 is 4k minus 30. Is this okay? Dividing everyone by 2, I get k square plus 2k minus 15. So check on this. Is this correct? So we get here k minus 3 and k. So which means k minus 3 is 0 or so we get k is 3 or k is minus 5. Okay, wait. We are not done here. There's a small problem. Do you see in here the area of object you are supposed to multiply with the determinant of the matrix, right? And when we say determinant of matrix, you know, we are supposed to use the positive value of the determinant. Okay, meaning we are, can you see I have used the modulus sign here. The modulus sign means you must use the, now here, basically I should use the modulus sign here. So when I use the modulus sign here, okay, so when I use the modulus sign here to remove the modulus sign, okay, so I have taken one path here, one way of removing the modulus sign is by taking the positive side of the modulus. Okay, so there is another path you need to consider when you are removing the modulus. Look at this. The other way is what? To remove the modulus. The other way is you must consider this path also to remove the modulus. You have taken the negative side of this modulus, which is what? Positive k square minus 6k minus 15 equals to 16k. Look at this. When you have the modulus sign like this with an unknown term, okay, whenever they give you the modulus sign with an unknown term, so then if you know the modulus, there's no problem. If you know the value, you can just remove the negative sign and put it. If you know the constant value. The problem here is your modulus is given in terms of an unknown k. So when they give you your modulus in terms, the determinant in terms of an unknown person and you're taking the modulus of it, to remove the modulus, children, you must consider the positive part of the modulus separately in one equation and you must consider the negative part of this modulus in a another equation. You have to do that. Okay, look. So I have taken the negative part, so I multiplied with the minus sign, and that's why it became plus k square minus 6k minus 15. So open the bracket, I end up getting here 2k square minus 12k minus 30 equals 16k. Can I have the answer here? 2k square minus 12 minus 16 is minus 28k. Is that correct? Divide everyone by 2. K square minus 14k minus 15 equals 0. Can you all factorize this? What do I get for the two factors? K plus 1 and k minus 15. So I end up getting here k equal minus 1 or k equal 15. Are you okay with it? We are not done yet. Okay, now thing is this. You know this, we only need to choose the k values. Okay, we only need to choose the k values who gives us what? Who makes this determinant of m what? Positive. We need to choose the k values who make our determinant m positive. Okay, so can you all choose the k values who makes this determinant m positive? So for this det m, I got this for this particular minus k square plus 6k plus 15, I got the k value 3 and minus 5, right? So when k is 3, I think you can see I get my det m is positive, right? When k is 3, yeah, it becomes det m is 24 positive. And then when k is minus 5, we get det m is minus 40, right? Can you see? Actually, you know, I mean, it's fine. Actually, you can give all your answers. You don't need to check the determinant whether it's positive or negative because we basically consider the modulus of it. Okay, so they have checked and, you know, they've given you marks if you have rejected the values that are the values that are negative. Okay, have they told you where k is positive? Have they told you anything like that? No, right? Yeah. So actually you can give all the values for k. You don't need to do this. You don't need to do this. Okay, you could give all the values for k basically, even because if you put k is 5, your determinant is negative, but you take the modulus of it, right? Yeah, it's okay. We can leave it like this. All these answers for k are fine. Okay, so determine all the possible values. So these are all the possible values for k. Okay, question number 8. The parabola C has equation y square equal 20x. The point P on C has coordinates 5p square, 10p, where p is a non-zero constant. Use calculus to show that the tangent to C has at P has this equation. Okay. So we have a parabola. We don't need to draw any of this. The parabola has equation y square equal 20x. The point P. So we have a point P on the parabola, which is 5p square, 10p. Use calculus to show that the tangent. Okay, we need to get the equation of the tangent at this point. Okay, so how do we get the equation of the tangent? Always the first step in finding the equation of the tangent is dy by dx. Okay, so for the people who have done P3, P4, differentiating y square equal 20x is quite simple. You can give the power priority rule and do it. But for the others who haven't done it, you could make x the subject. Look at this. Make x the subject, x equals y square over 20, right? You remember x equal y square over 20. And now you can differentiate keeping treating x like y and y like x. This is the way we've done it, right? So when you differentiate x, what do we get? We get d instead of dy by dx, we get here what? dx by dy. dx by dy. Here we get 1 over 20, let it be there. Y square differentiation is like we differentiate x square, you get 2x. So y square differentiation is 2y. This is okay. So dx by dy equal, this is the way to do it if you have not done P3, P4. But the others, you could use the power priority rule, differentiate the y square, taking the power 2 in front. right? Yeah, you could take 2y to the power 1 times dy by dx equals 20. And then you end up getting dy by dx is 20 over 2y, which is exactly the same thing that I'm getting even from the other method. So I get here dx by dy is 2y over 20. So 2 and 20 cancels. 2 times 1 is 2, 2 times 10. So dy by dx is the reciprocal. Take the reciprocal, 10 over y. The same as this 20 and 2 cancels to give you 10 over y. Whichever way you go is fine. So for the people who are not familiar with the P3, P4 differentiation, this is how we do it. Okay, keeping x in front and differentiate x. Okay, with respect to y, we differentiate and then we convert, take the reciprocal. Okay, so now I have the gradient. I have the equation for the dy by dx or the gradient of the tangent. What should we do? Replace the xy values in the gradient. So here our y value should be replaced. What's the y value? Y value is 10p. Replace 10p. So gradient of tangent dy by dx equals 10 over y. Y is 10p. So what happens? 10 and 10 cancels and gradient of tangent is 1 over p. Do you agree? Now let's get the equation of tangent. So what is the equation of tangent? Y minus y1 equals gradient x minus x1. Y minus y1 equals gradient times x minus x1. So y minus, what is y1? Y1 is the 5p square comma 10p. This is x1 y1, right? Y1 is 10p, gradient is 1 over p, x minus x1 is 5p square. Take the p to the other side and get the show that here the p multiplies with both y and minus 10p. Y into p is py, minus 10p into p is 10p square, x minus 5p square. Get the show that has py minus 6, right? So I'll take the x here and take the minus 10p square here. Py minus x equal plus 10p square minus 5p square. Py minus x equal 10p square minus 5p square is 5p square, which is our show that. This is the show that. The tangent to the curve at P meets the y-axis at the point A. So basically, we found the tangent to the curve at point P in part A. This is the equation. It was to show that. So this tangent meets the y-axis at the point A. So when you meet the y-axis, what do you need to do? So when you meet y-axis, part B, when you meet y-axis, x is 0. Take the tangent equation and make x 0. Py minus x equal 5p square. So x is 0. So what do we get here? Py equals 5p square. Y equals 5p square over p, which is 5p. Okay, so this is the coordinate of the point A. So write the coordinates of point A. Point A is 0, 5p. The coordinates of A is 0, 5p. Move on. Next point, the point S is the focus of C. Write down the coordinates of S. Okay, the focus coordinates of a parabola. So these are things that you need to already remember. A parabola equation is supposed to be in the format y square equal 4ax and the focus will be a comma 0. The focus should be at a comma 0 and the directrix is at x equal minus a. So those are the rules. So basically if you have y square equal 20x, so then what is the focus? This is part C, right? So part C, y square equal 20x means we need to break it with 4. So y square equal 4 into a is 5. So basically your a value is 5. So if your a value is 5, then focus will be 5, 0. The focus point will be 5, 0. Using the theory that I gave you here, if you the equation 4ax has focus a, 0. Okay, then the next one, The straight line L1 passes through A and S. Okay, so what is A now? A is the place where you meet the y-axis, right? So this is the y-axis A and this is S. Let's say S is over here. What was our A coordinate? 5, right? 5, 0. So this is S. They say the straight line L1 passes through A and S. So I'll draw a diagram roughly. So the straight line L1 passes through A and S. Can you see? This is straight line L1. Line 1. The straight line 2 passes through O and P. Okay, who is O and P? O is the origin, right? And P is this point over here. So the straight line 2 passes through O and P. This is line 2. Are you with me? The straight line 2 passes through O and P where O is the origin. Line 1 and line 2. Do you see? Line 1 and line 2 intersect at the point B. Can you see the point B? Point B is the place where line 1 and line 2 intersect. Show that the coordinates of B satisfy the equation 2x square plus y square equal 10x. Shall we work on this? Okay, how do we get this? Show that. The first thing is this. Now it's 5 marks. You can see most of the marks in this paper, most of the marks in this question go to this part. Okay, so how do we do this now? First thing is you have to find the equation that passes through A and S. Next thing is you have to find the equation that passes through O and P. And then you have to solve those two lines simultaneously. Okay, let's do that first. The A coordinate was found, right? What was the A coordinate? A coordinate was 0, 5p. Okay, let's mark it here. A coordinate is 0, 5p. Okay, so I have the S coordinate was 5, 0, right? This is a 5. Okay, let's get the gradient of AS. This is part D. So what is the gradient of AS? A to S, what's the gradient? Y difference over X difference, right? 5p minus 0, are you looking at it? 5p subtracting with 0 and 0 subtracting with 5. Y difference over X difference, right? What do you get for the gradient of AS? 5p divided by minus 5 is minus p. Do you see it? Gradient of AS. Now get the equation of AS. Y minus y1, gradient x minus x1. So for x and y, you could use either 0, 5p or you could use 5, 0. Shall I use 5, 0 for x1, y1? Y minus y1 is 0, gradient is minus p, x minus x1 is 5. Are you with me? So I get here y equal minus px, minus p into minus 5 is plus 5p. Y equal minus px plus 5p. This is the equation of line 1. This is line 1 equation. Now let's get the line 2 equation. Line 2 is the line passing through O and P. So let's get the gradient OP. What is the gradient OP? Y difference over X difference. Y difference is 10p. O is 0, 0, right? 10p minus 0 over 5p square minus 0. What's the gradient? 10 and 5 cancels. You get 2 on top. A p to p cancels and a p remains at the bottom. 2 it remains on top, p remains at the bottom. Is that clear? So then let's get the equation of OP. So what is the easiest to use for y minus y1? X minus x1. For x1, y1, because the line passes through the origin, it's best you use 0, 0. Okay. So y minus y1 is 0. Gradient is 2 over p. X minus x1 is 0. So basically I get y equal 2 over p times x, and this is my line 2. This is my line 2. Now all I need to do is solve these two equations simultaneously and get an equation relating and get the point where the lines 1 and line 2 intersect so that I can find the coordinates of point B. Okay. So let's solve line 1 and line 2 simultaneously. Shall we equate them? Both of them have y equal minus px plus 5p, y equal to over px. I'll equate them. Minus px plus 5p equating with 2 over px. Is okay? So when I need to make x a subject, right? I need to make x a subject. Shall I multiply the whole equation with p? Remember, we are trying to find a coordinate. We are trying to find solve the pair of equations simultaneously. Basically, finding x and y is our target. So multiplying everyone with p. So I end up getting here p into px is minus p square x. 5p into p is 5p square. 2 over p into x is 2x because the p will cancel out. So 5p square equal, taking all the x terms to one side, 2x plus p square x. Take the x out, 2 plus p square. So basically I get x equals 5p square over 2 plus p square. Okay, now substitute the x value into the equation and find y also. So y equals, let's substitute to line 2. Y equal 2 over px, replace. Yeah, whatever you use, you should get the same answer. X is 5p square over 2 plus p square. So here p to p cancels, right? What do you get here? Y equal 10p over 2 plus p square. This is what we get. Okay, so we are not done yet. We have to get the show that now. Okay, so this is the show that I need to do. Né? So what we'll do is I'll create the x square and I'll create the y square and we'll add 2x square plus y square and see whether we can create the 10x. Okay, shall we try that? We can do it like that. So 2x square, what is the x is 5p square over 2 plus p square, right? So who is x square then? X is 5p square over 2 plus p square, just the p square. X square means you have to square the whole thing, isn't it? So then what is x square? We get here 5 when you square the 5, you know the power 2 will go to everyone here, right? You get here 5 p to the power 4. Are you with me? 2 plus p square, whole thing square. Look at this. The power 2 comes to the 5, the power 2 comes to the p square, and the power 2 comes to the 2 plus p square. It's a positive, so because of that, you put a bracket around and put the square. Similarly, do for y square also. Y is 10p over 2 plus p to the power 2 close bracket. Now, when you take y square, what happens? Put a bracket and square the whole thing. So, y square is in here it should be 25, right? 5 to the power 2 is not 5. 5 to the power 2 is 25. 5 to the power 2 is 25. P to the power 4. Yeah, this one 10p square. The 10 also gets the square, so it becomes 100. P gets the square, it's p square. Here I get 2 plus p square square. Are you with me? Okay, now shall we try 2x square plus y square? Add it and see. Add 2x square plus y square. 2 times x square is 25 p to the power 4 over 2 plus p square square. Adding with y square is 100 p square over 2 plus p square square. Now, do I need to take any common denominator here? No, you can see common denominator is already there. 2 plus p square square is already there. So 2 times 25 is 50p to the power 4 plus 100p to the power 2. Do you agree? Take a 50 and take the common thing out. We can take a 50 and a p square out, right? So I get p square plus 2. Do you agree with me? 2 plus p square square. Now what happens? A p square plus 2 is down and a p square plus 2 down is there in the denominator, and in the denominator is a square. You can cut one bracket here. In the denominator there is a pair of it because it's a square. I can cut one out of it. So I get here 50p square over 2 plus p square. Now I need to show it's 10x, right? So 10x means like 2x square plus y square is 10x. So 50 I can break it as 10 times 5. So 10 times this is 5p square over 2 plus p square. So can you see 5p square over 2 plus p square is a x. And you see 5p square over 2 plus p square is the actual x. So this is 10x. So this is your x. Can you see the show that? So this is how it's done. Okay. Okay, question number 9. The sequence of numbers is defined by u1 equals 0, u2 is minus 6, and they have given you a recurrence formula, right? Un plus 2 equal 5un plus 1 minus 6un, where n is greater than or equal 1. Prove by induction that for n is an element of positive integers, un equal 3 times 2n minus 2 times 3n. Okay. Now the thing is this, you know, in a recurrence formula, okay, you know, a recurrence formula is a formula where you need to go in order, right? Can we find terms in the middle? No. So then they have given you this un here is the formula we are going to use instead of the recurrence formula. In this un equation, we can find any term we want, right? Even in the middle. If I want to find the 10th term, I can find it, right? But when I use the recurrence formula, I can't find the 10th term if I want, because we have to go in the order. So then what are we trying to prove now? The recurrence formula is like our main formula. We are trying to prove this equation, the one that gives you the term at any point. At any point, you need to show that the terms you get from the UN equation is the same as what you would get from the recurrence equation. Are you with me? Okay, so what you need to do is first things first. First, we need to prove that the general result. Okay, we have to prove that the general result is true when what? Is true for the first term, whether we get u1 correctly. So let's do here. In the recurrence relation, what is the first term? u1 is given to you in the recurrence relation, right? Look at this. u1 is given to you in the recurrence relation. What is the u1? u1 is given as 0. Okay. Then let's get the let's get from the other one. The general let's get it from the other one. Okay, so the general statement is what we need to try to prove here. So this is the general statement. Okay, so from the recurrence relation, they have given us the first term is 0. Can you tell me the first term for the recurrence relationship? For the general statement, u1 equals, input the value 3 times 2 to the power 1 minus 2 times 3 to the power 1. What do you get here? 6 minus 6 is 0. So I think you can see the first term is matching for both. Okay, next one. Let's try the second term. U2 is also given, U1 is given, U2 is also given in the recurrence relation, right? U2 is minus 6. Check the general statement. So U2 will be what? 3 times 2 to the power 2 minus 2 times 3 to the power 2. Can I know the answer? 3 times 2 to the power 2 is 4. 4 times 3 is 12. 2 times 3 to the power 2 is 9. 9 times 2 is 18. The answer is minus 6, right? Now, did you notice that I didn't use a recurrence relationship even once? Did I use this equation once to at least get even one term? No, so then it's customary, it's normal, traditional that we use the recurrence relationship at least once, to get one term and compare it with the general statement. So that means from the recurrence relationship, I will find which term now? I will find the third term. Let's get the third term, U3. Let's compare third term. I want you to compare the third term also because we need to use the recurrence relation at least once. So U3, what do we get for the third term? So for the third term, you must replace the n here with 1, right? When you replace the n here with 1, you get U3 equals, please respond, U3 equals 5. U1 plus 1 is U2 minus 6U1. U3 equals 5U2 minus 6U1. Replace 5 times the second term is minus 6. 6 times first term is 0. What do we get here? Minus 30 minus 0. Answer is minus 30. You see? Okay, get the third term from the general statement as well. U3 from the general statement, we get 3 times 2 to the power 3 minus 2 times 3 to the power 3. What do we get here? 3 times 2 to the power 3 is 8. 8 times 3 24. 3 to the power 3 is 27 times 2 is 54, right? Minus 30. Can you see the answer for the recurrence and general statement? They actually match. Even for third, but the thing is, we can't keep on doing like this. So we need a general way to prove. So what do we do? Now we go in induction. We always go for the assumption. We assume that the result is true for what? When n equal k. However, because we are dealing with the n plus 2 type of equation here, we in this kind of equation we assume the result is true not only for n equal k, because there is a un and un plus 1 here. We assume the result is true for u k n when n equal k n when n equal k plus 1. So let's do it. Assume general statement is true for n equal k and n equal k plus 1. So when n equal k, what's your general statement? uk equals, tell me, the kth term is 3 times 2 to the power k minus 2 times 3 to the power k. Is that okay? And the k plus 1 statement from the general is 3 times 2 to the power k plus 1 minus 2 times 3 to the power k plus 1. So these are the two assumptions. We assume that both of them are true. So that means I assume that the kth term I get from the general is exactly the same as I would get from the recurrence. That's the assumption, right? And I assume that the k plus 1 term that I get from my general statement is the exact same as I would get from the recurrence. Now what do we do? The next step of induction is we go for the next term. We go for the k plus 2 term. And when we go for the k plus 2 term, what do we need to show? We need to show that the k plus 2 term in the k plus 2 term in the recurrence is the exact same as the k plus 2 term in the general. Okay, so let's go with the recurrence. Get the k plus 2 term from the recurrence. From the recurrence relationship. From the recurrence relation, let's get the k plus 2 term. Is it difficult to get the k plus 2 term from the recurrence? All you have to do is replace the n with k, because you can see when n is k, we get k plus 2. uk plus 2 means the k plus 2 term, right? So write uk plus 2 from the recurrence equals, tell me the recurrence equation, uk plus 2 equals 5uk plus 1 minus 6uk, because basically in the recurrence the k already I have n plus 2 here. All I have to do is replace n with k and I get the k plus 2 term. Okay, the k plus 2 term. So now let's substitute the value here. You can see here the kth term and the k plus 1 term are already what? Assumed. We have found, we have said that these terms are correct. So let's get it. uk plus 2 equals 5 times the k plus 1 term is 3 times 2 to the power k plus 1 minus 2 times 3 to the power k plus 1 minus 6 times the kth term is 3 times 2 to the power k. And by the way, before we try to blindly simplify, it's better that we have an idea of what we need to get, right? That means we need to get the k plus 2 term from whom? From the general statement. Get the k plus 2 from the general statement, because then we need to know, because we need to check whether the recurrence relation k plus 2 term and the general statement k plus 2 term are the same. That's what we need to do. So let's get the k plus 2 here. uk plus 2 from the general statement gives me, look, 3 times 2 to the power k plus 2 minus 2 times 3 to the power k plus 2. Okay, so this is my goal. If I can get this, that means the general statement, if I can get the same answer for this from my recurrence relationship, that means this is correct. The proof by induction is done. So shall we simplify? So what do we get here? 5 into 3. Shall I directly write 15? By the way, you do realize you can't multiply the 3 and 2 and write 6 here, right? Because the 2 has a power. You should not multiply anyone who has a power with any other number. The 5 and 3, however, can multiply. 5 times 3 is 15 times 2 to the power k plus 1. You don't multiply the 5 with 2. Do not do stuff like that. Here minus 5 times 2 is 10 times 3 to the power k plus 1. And finish this off. The next part. 6 times 3, 18 times 2 to the power k minus minus plus. 6 times 2, 12 times 3 to the power k. Now simplify the like terms. So actually, how do I make the like terms? You can see here I have 2 to the power k, 3 to the power k. Here I have k plus 1. Shall I make these people also k plus 1? We can make them k plus 1, right? Or you could make the k plus 1 powers become k powers. It's entirely up to you. Shall I make them k plus 1 into k? Anything is fine.
A into K plus 1.
Okay, we'll do k into k plus 1. So 18 can be written as what? 9 times 2. 18 can be written as 9 times 2 times 2 to the power k. Do you see what's the strategy here? 12 can be written as 4 times 3. So we get here 15 times 2 to the power k plus 1 minus 10 times 3 to the power k plus 1. Here minus 9 times what happens? 2 to the power 1 and 2 to the power k is 2 to the power k plus 1 plus here 4 times 3 to the power 1 and 3 to the power k. When you multiply 3 to the power k plus 1. Do you see? So now I have like terms. 15 times 2k plus 1 minus 9 times 2 to the power k plus 1. So this is 15a minus 9a. 15 minus 9, these are like terms. Do you see? These two like terms, 15 minus 9 is 6 times 2 to the power k plus 1. The other two pair of like terms are minus 10 3k plus 1 plus 4. Minus 10 plus 4 is minus 6 3 to the power k plus 1. So let's break it. The 3 we can break it as 3 times 2, right? Times 2 to the power k plus 1. Minus the 6 we can break it as 2 times 3. Do you see how this works? So 3 times 2 to the power 1 and 2 to the power k plus 1. When you add, you get 2 to the power k plus 2. Here 2 times 3 to the power 1 and k plus 1 adds to give 3 to the power k plus 2. Which is a show that and which is exactly what we wanted. So we got the same answer for the k plus 2 term as we would get from the general statement. We got it from the recurrence relation. So therefore, therefore, general statement is true for un plus 2, the n plus 2 term. Therefore, general statement is true, or you can say result is true for all un, where n is greater than or equal 1. By mathematical induction. Okay, then we'll move on to the last part, the divisibility result. Okay, shall we move on to the last part? Okay, prove by induction that for all positive integers n, fn equal 3 to the power 3n minus 2 plus 2 to the power 4n minus 1 is divisible by 11. Okay, so how do we do prove divisibility results? So first we'll say fn, they have given fn is 3 to the power 3n minus 2 plus 2 to the power 4n minus 1. So first thing is, before we go to prove, to prove it divisible by 11, you had proof for every positive integer n that the answer for this particular expression will always be divisible by 11. So let's at least, what do we need to do? First we need to check whether is it divisible at least by 1. When n is 1, at least when n is 1, it's the very first result, right? Is it divisible by 11? So let's check. When n equal 1, what do we get? F1 equal 3 to the power 3 into n is 3 into 1 minus 2 plus 3 to the power 4 into 1 is 4 minus 1. What do we get? 3 to the power 1 plus 2 to the power 3. What is it? 3, 2 to the power 3 is 8. 8 plus 3 is 11. So what do we see? 11 is divisible by 11, right? Is divisible by 7. Is divisible by 11. So you can say result is true. The result is true for n equals 1. Okay, then what's the next step of our next step of induction? Assume Fn is divisible by, assume Fn is divisible by 11 when, assume Fn is divisible by 11 when n equals k. So when n equals k, what do we get? Fk equals 3 to the power 3k minus 2 plus 2 to the power 4k minus 1. So we need to prove that it's divisible by, we assume that fk equal 3 to the power 3k minus 2 plus 4 to the power 4k minus 1 is divisible by 11. Is that clear? Okay, now what do we need to do? Now we go for the k plus 1th term. Now k plus 1th term is what we need to manually show that the k plus 1th term is divisible by 11. Or basically, if you can take a factor of 11 out, then it's correct. So f of k plus 1. So for fk plus 1, let's go for the fk plus 1. What is fk plus 1? In fk plus 1, you can directly replace the n with k plus 1. All you need to do is from the fk plus 1 term, if we can take 11 out, then we are correct. Then we are done. Because I want to show that the k plus 1 term is divisible by 11. Do you get me? So what is fk plus 1? 3 to the power 3 times. Replace the n with k plus 1. Minus 2 plus 2 to the power 4 times n is k plus 1 minus 1. So I get here f of k plus 1 is 3 to the power 3k plus 3 minus 2 is plus 1. Plus 2 to the power 4k plus 4 minus 1 is plus 3. So this is f of k plus 1. Do you think I have any way of taking 11 outside of this? Doesn't look like we can take 11 outside of this, right? What we'll do now is, normally the traditional thing we do is we go for fk plus 1 minus fk. That is the thing we do normally, because we are allowed to use, we need the help of our fk as well. So traditionally what we do is we use the help of, we get fk plus 1 minus fk. So fk plus 1 is 3 to the power 3k plus 1 plus 2 to the power 4k plus 3. We subtract with fk. What's our fk? 3 to the power 3k minus 2 plus 2 to the power 4k minus 1. Now I think you can see here the powers are quite different, right? 3 is power. Now, do you think we can simplify when these powers are different? No, we can't. So one of the best advices that I can give you here is, when you are doing this fk plus 1 minus fk, always keep your fk plus 1 in the same powers of fk. Now you can see here fk is having 3 to the power 3k minus 2, right? So try to make your fk plus 1 also have those similar kinds of powers. Are you with me? So basically, I think I could have done it from the beginning here. Okay, so instead of coming to this point and getting stuck, now you can see we can't simplify. Okay, we can, the best way to get the answer easily is to have fk plus 1 in the same powers of fk. Okay, shall I do like this? Look, have a look here. Instead of doing it the way I did here, do you agree if I do like this? Now I want to have the same powers of fk, right? So here, now I want to have a 3 to the power 3k minus 2. So do you see here, I get 3 to the power, when I open this 3k, and do you see the minus 2 is there here separately? And do you see there's a separate plus 3? Look at this, look at what I did here. 3 into k is 3k, and there is a minus 2, and 3 into 1, 3 I wrote at the end. Did you see what I did here? Likewise, go for the 2 also. Plus 2 to the power, you get here 4 into k is 4k. 4 into k is 4k. Plus 4 into 1 is 4. Don't write the 4. Because I want 4k what? Minus 1. Because fk has 4k minus 1. So I'll bring the minus 1 here. And 4 into 1, 4. I'll put it at the corner. Is that okay? And then let me remove this. So then what I'll do here is, now I'll separate. 3 to the power 3k minus 2 into 3 to the power 3. Do you see what I did here? 2 to the power 4k minus 1 into 2 to the power 4. So you can see now my fk plus 1 and fk are having the same powers. And you see the addition means we can separate it as multiplication, right? So 3 to the power 3 is 27 times 3 to the power 3k minus 2 plus 2 to the power 4 is 16 times 2 to the power 4k minus 1. Can you see the f of k plus 1 now? So when you make it to this format, now it's suitable to subtract fk plus 1 minus fk. Let's subtract fk plus 1 is 27 times 3 to the power 3k minus 2 plus 16 times 2 to the power 4k minus 1. We subtract with fk is what? 3 to the power 3k minus 2 plus 2 to the power 4k minus 1. So what do we get here? 27 times 3 to the power 3k minus 2, 16 times 2 to the power 4k minus 1. See, I get minus, right? Minus 3 to the power 3k minus 2, minus into plus is minus 2 to the power 4k minus 1. So basically there's no number in front, means you can think it's a 1 times. Because we can simplify like terms. The whole point of making fk and fk plus 1 having the same powers is so that we can simplify. So you can see here I have 27 3 to the power 3k minus 2 and 1 3 to the power 3k minus 2 here. What happens? 27 minus 1 is 26 times 3 to the power 3k minus 2. And here 16 and 16 2 to the power 4k minus 1 and 1 2 to the power 4k minus 1. So that gives me 16 minus 1 is 15 times 2 to the power 4k minus 1. Okay, now I need to still get 11, right? I need to get 11 out front. Am I still getting 11 here? No, right? Not yet. What I'll do is this. Can you see I have 26 of these 3 to the power 3k minus 2s and I have 15 of this amount. So basically it looks like this. It looks like I have 26 A's and let's say I have 15 B's. So 26A and 15B, can't I break this 26A? Now here we have lesser amount of B, 15B. Can you break the 26A also with 15A's and how many A's are remaining there? 26A, now I have 15B here, right? So if there's 15B here, and if I want to create 26A, let's break it 15A, then how many other A's are remaining from 26? 11A, right? 11A plus, the reason I broke it into 15 is because the other guy has 15 here. This has 15, so I thought, okay, 26A also I break it as 15 A's, then another 11 A's remain. Are you getting what I'm doing here? So likewise, do it here. 26 3 to the power 3k minus is 11 times 3 to the power 3k minus 2 plus 15 times 3 to the power 3k minus 2 plus 15 times 2 to the power 4k minus 1. Are you with me? Now what I can do here is 11 times 3 to the power 3k minus 2. I can take the 15 out. When I take the 15 out, what do I get? 3 to the power 3k minus 2 plus 2 to the power 4k minus 1. Who is this? This is not k. This is fk. This is fk. So 11 times 3 to the power 3k minus 2 plus 15. 3 to the power k minus 2, 2 to the power 4k minus 1 is our fk. This is, so this is the answer for fk plus 1 minus fk, right? Now I need to prove fk plus 1 is divisible by 11, right? So keep the f of k plus 1 here, take the minus fk to the other side. 15 fk plus 1 fk is 16 fk. So I think now you can see we got what we wanted, right? The k plus 1 term is divisible by 11, right? Because this term is having 11, we can clearly see it. And the other term, fk, is anyway, we assume it's divisible by 11. So both of them are having a factor of 11, which means this whole term is divisible by 11. Therefore, so you can see, therefore, result is true. Or you can see it is divisible by 11. Result is true for n equal k plus 1. The result in the sense, I mean the division, the divisibility by 11. Therefore, result is true for, therefore the result is true for all positive integers n by mathematical induction. By mathematical induction. Okay, so this is the end of our paper.